It's on a scale that's hard to take in. The size of 600 football pitches, this colossal construction site is where a record-breaking tunnel is being built, running 18 kilometers under the Baltic Sea. Beneath the turbulent waters of Asia's most unpredictable river, a silent revolution took shape, one that shattered records, defied limits, and turned a city's greatest nightmare into its most daring triumph. At first glance, it sounds like fiction, a colossal underwater highway built not in years but in a mere 110 days. Yet this isn't just a story of speed. It's a masterclass in precision, defiance, and raw engineering brilliance. What sparked it wasn't just ambition, it was survival. What followed wasn't luck. It was something far more calculated. Hidden within this feat is a move so audacious, so counterintuitive, it forced engineers to abandon everything they knew about bridges and dig deeper than ever before. When the surface betrays you and time is your enemy, what do you build? In the heart of China, one city found its answer not above the river but beneath it. And what they created down there, you'll have to see it to believe it. The crisis that forced a megaproject into existence. For years, Gannon's traffic was among China's worst, a paradox for a booming economic hub in Shandong province. By 2020, the city streets, built for a fraction of its current population, choked under 3.5 million vehicles. Gridlock wasn't just an inconvenience, it was an economic stranglehold, costing an estimated $2.3 billion annually in lost productivity, wasted fuel, and supply chain delays. The Yellow River slicing Gannon in two became the city's cruelest bottleneck. Two outdated bridges, never designed for modern traffic, turned into parking lots during rush hour. Accidents, weather, a single hiccup triggered citywide paralysis. The stakes were existential. Gannon's northern districts, ripe for industrial parks, logistics hubs, and housing, remained cut off from the urban core. Investors hesitated. Growth stalled. The city needed a solution not for today, but for decades ahead. After years of studies, one radical idea emerged, a massive underwater highway tunnel capable of moving tens of thousands of vehicles daily without touching the river's surface. By 2023, the plan wasn't just a blueprint, it was a countdown to revolution. But one question lingered: why not just build another bridge? Why a bridge would have been a disaster? On paper, more bridges seemed like the obvious fix. But the Yellow River, nicknamed China's Sorrow, had other plans. Its banks were geological nightmares, shifting violently with seasonal floods. Anchoring a new bridge was nearly impossible without risking collapse. Worse, much of the river was a protected ecological zone, home to 160+ fish species. Dredging for bridge foundations would have triggered an environmental catastrophe and violated strict national laws. Then came the human cost. The only viable bridge paths cut through densely packed neighborhoods, demanding the relocation of 240,000 people. The price? Billions in compensation, demolished homes, and political fallout. Faced with impossible trade-offs, Gannon's planners realized the solution wasn't above the river, it was under it. A tunnel could bypass the chaos, leaving ecosystems untouched and communities intact. It wasn't just bold, it was the only way out. The underground revolution. Inside the double-decker wonder beneath the Yellow River's restless currents lies an engineering masterpiece that defies conventional tunnel design. Engineers didn't just build a passage, they created a vertically stacked transportation ecosystem, packing two independent three-lane highways into a single gargantuan bore. The upper and lower decks operate as synchronized unidirectional roadways, their opposing flows eliminating the deadly risk of head-on collisions while doubling capacity. Smart systems transform this subterranean highway into a living organism. AI controllers constantly analyze traffic patterns, dynamically adjusting vehicle flow to prevent congestion before it forms. The tunnel breathes through a network of massive ventilation shafts, while thousands of daylight simulating LEDs combat driver fatigue during the 3-minute underwater crossing. Safety reaches new heights with emergency escape corridors suspended safely above potential flood levels, accessible every 200 m via crush-resistant stairwells. The true marvel lies in its backbone, a central composite spine engineered to absorb the river's constant assaults. This revolutionary load-bearing core distributes immense hydrostatic pressures while dampening seismic vibrations, its flexible design allowing the entire structure to sway slightly with Earth movements. Every component, from the nano-coated concrete walls to the vibration-dampened expansion joints, works in harmony to create what might be the most advanced underwater roadway ever conceived. Not just solving today's traffic woes, but future-proofing the city for generations to come. Engineering against the clock, the 110-day underwater miracle. When engineers announced they'd burrow beneath the Yellow River in just 110 days, skeptics called it impossible. Then came Shan-Hai, a 80 million mechanical titan built specifically for this David versus Goliath challenge. This 17.5 m wide behemoth packed 7,510 horsepower of raw tunneling power, its 800-plus sensors creating a real-time nervous system that made micro-adjustments before humans could blink. The river fought dirty. Unstable soils turned liquid. Hidden granite formations appeared without warning. Quicksand threatened to swallow progress. But Shan-Hai answered with foam injections that solidified treacherous ground and an AI brain that recalculated strategies in milliseconds. When a massive boulder blocked the path, the machine adapted in seconds, a fix that would have stalled human crews for hours. By December's end, the impossible became reality, 3,290 m of pristine tunnel carved beneath one of Earth's most temperamental rivers. The world record wasn't just about speed, it was about proving that with the right combination of cutting-edge technology and human determination, even nature's most daunting challenges can be conquered on an unprecedented timeline. The river's fury meets human ingenuity. Nature threw everything it had at this project, and engineers responded with equal force. The Yellow River's shifting sediment transformed entire sections into treacherous underwater quicksand, while crushing 7.5 bar pressures threatened to implode the tunnel at its deepest points. When hidden water channels burst through the work site, crews raced against time to deploy emergency seals before the river could reclaim its domain. Each challenge sparked brilliant countermeasures, foam injection systems that stabilized unstable soil like geological glue, laser-guided ring placement accurate to within the width of a pencil lead, and an unprecedented 98% material recycling rate that turned excavated earth into new infrastructure. What began as a construction project became something far more dramatic, a relentless, high-stakes battle of wits against one of Asia's most unpredictable waterways. In the end, the river met its match. Through sheer engineering brilliance, Gannon didn't just survive the Yellow River's wrath, it emerged victorious. Proving that even nature's most formidable obstacles can be overcome with enough innovation and determination, the tunnel stands today not just as infrastructure, but as a monument to humanity's ability to outthink the elements themselves. The legacy, 43 game-changing innovations that redefined modern engineering. This mega-project didn't just break records, it completely rewrote the engineering playbook, generating an astonishing 43 groundbreaking patents that are already transforming global infrastructure. At the heart of its legacy lies revolutionary concrete technology that defied conventional curing times, hardening 30% faster while maintaining exceptional strength. A breakthrough that shaved critical days off construction timelines. The tunnel's true genius revealed itself through AI-powered precision systems that operated with almost clairvoyant accuracy, automatically adjusting torque and pressure in real time to prevent jams and keep the massive TBM boring forward without interruption. Its unprecedented 17.5 m width didn't just set a world record, it established an entirely new paradigm for underwater infrastructure, proving that wider could indeed be smarter when engineering two stacked highways within a single bore. Beyond raw engineering prowess, the project pioneered eco-conscious construction methods that redefined sustainable mega-projects. With patented sediment control systems and waste reduction techniques minimizing environmental impact, its next-generation safety protocols, from advanced fire suppression to emergency ventilation systems, have since become the gold standard for underwater infrastructure worldwide. These innovations collectively represent more than technical solutions, they form a blueprint for 21st-century urban development. The AI algorithms that maintained construction momentum, the materials science breakthroughs that enabled rapid building, and the operational strategies that conquered impossible deadlines have all become case studies in modern engineering. Gannon's tunnel stands as proof that when faced with unprecedented challenges, human ingenuity doesn't just adapt, it reinvents the rules entirely. The technologies pioneered here are already being adapted across continents, from alpine passages to Amazonian crossings, marking this project not as a local solution but as a global game-changer. Future engineers will look back at this achievement as the moment tunneling stepped into a new era, where artificial intelligence, environmental stewardship, and sheer ambition converged to build what was once considered unbuildable. The final twist: redefining the possible. Most tunnels compete on length. Gannon's competed on sheer scale. At twice the width of the Channel Tunnel, it proved sometimes the solution isn't longer, it's wider, smarter, and deeper. And that's how China pulled off the impossible: faster, bolder, and against all odds. From battling a vengeful river to rewriting engineering limits, the Gannon-Huang Road Tunnel didn't just fix traffic, it changed the game. Was this the most insane engineering feat you've ever seen? Drop a comment with your favorite moment. Smash like and subscribe for more jaw-dropping mega projects. Oh, and don't click away yet. Another unbelievable build is waiting. You won't believe what they did.